In 1977, the Research Communications Network published a special breakthrough report on the results of Dr. Gentry's scientific publications, characterizing their implications as follows. Current physical laws may not have governed the past. Earth's primordial crustal rocks, rather than cooling and solidifying over millions of years, crystallized almost instantaneously. Some geological formations thought to be 100 million years old are in reality only several thousand years old. Grant these propositions and any researcher will tell you the entire structure of the historical natural sciences would dissolve into formlessness. Few certainties would remain. Yet these very possibilities, and others equally challenging, have been suggested in a remarkable series of papers published over the past several years in the world's foremost scientific journals, Nature, Science, and Annual Review of Nuclear Science, among others. From Research Communications Network, Breakthrough Report 1977. Part of Dr. Gentry's work referred to in this quote pertained to his work with coalified wood from what is known as the Colorado Plateau, a broad geographical region encompassing parts of Colorado, Utah, Arizona, and New Mexico. Using the microscope and more advanced laboratory equipment, he analyzed these specimens of coalified wood for various types of radioactivity. His results help us to understand how long it takes coal to form, the age of the coal, and the age of the Earth itself.
One of Earth's vast energy resources. Before we can answer the question as to the age of coal and the time of its formation, we need to ask the question, where did coal come from? Here in this coal mine in Price, Utah, we have the answer. Here is a log, almost completely turned to coal. There are thousands of such logs in this mine and in other mines here in the Price area. This fact tells us that given the right conditions of pressure and temperature and water and time, that wood and other vegetation will turn to coal. The question is, how long did it take for that to happen?
Robert Gentry and his son David, an associate in his father's work, explore this topic together.
To answer this question, we need to look at coalified wood specimens from uranium mines instead of coalified wood, like this log, from one of the coal mines here in the Price, Utah area. This coalified wood specimen comes from La Salle, Utah, a uranium mine. Its presumed geologic age is around 140 million years.
This specimen of coalified wood comes from a uranium mine in the Temple Mountain area here in Utah. Its presumed age is also 140 million years. But look how closely this specimen resembles this other piece of wood. They're nearly identical. It's interesting to note that this other piece of wood was derived from a fresh piece of wood like this just a few weeks ago.
This close similarity raises an important question. Is it really true that this piece of coalified wood from La Salle, Utah, and this piece of coalified wood from Temple Mountain, Utah, are really 140 million years older than this piece of wood which David and I recently obtained in some of our experiments? Not really. Locked in these and other coalified wood specimens from uranium mines is some remarkable evidence that tells quite a different story. To see that evidence requires that the coalified wood specimens be mounted in epoxy, thinly sliced, and then placed on glass slides for observation under the microscope. Under the microscope can be seen discolorations produced by radioactive particles ejected from tiny centers. Some are circular, others are elliptical, as can be seen in these photographs. These circular and elliptical halos required a special sequence of events to form, so in fact that they completely overthrow the idea of an ancient age of coal, pointing instead to coal's recent formation, geologically speaking. To explain the halos requires that at one time, water-saturated logs were buried in what are now considered to be several different geologic formations: the Eocene, Jurassic, and Triassic. Later, uranium solutions infiltrated those water-saturated logs, and uranium decay products, radioactivity, was collected at tiny sites in each of those logs. That radioactivity decayed over the next several months to a half year, ejecting particles and producing spherical radiation-damaged regions, halos around those tiny sites. In cross-section, they appear to be circular. They were formed by the decay of secondary polonium, derived from the decay of uranium. Then there was a compression event. Something applied pressure to the top of all these formations. The logs were compressed, and when the logs were compressed, the halos were compressed. This brings us to an important point. We know that these logs had not turned to coal at the time the compression occurred. Here's a piece of coal. Coal doesn't compress. It shatters, as we can easily see. All the information we've seen thus far would indicate that these events were simultaneous in all these geologic formations. But there is even more evidence of that. When uranium invaded the wood, it left some of its decay product since the time that it invaded the wood. I measured both the amount of uranium in these coalified logs and also the amount of lead, the decay product. On the assumption that the decay of uranium to lead has been uniform, it's an assumption we'll discuss later, we arrive at the conclusion that all these logs were buried together quite recently. How recently? In 1976, I published my results of the studies on these logs in the October 15, 1976 issue of Science. Here's what I said in this report. Such extraordinary values, referring to these lead-uranium ratios, admit the possibility that both the initial uranium infiltration and coalification could possibly have occurred within the past several thousand years. In other words, I was suggesting that coal could form very rapidly, geologically speaking. It contradicted the conventional way in which people have thought about the formation of coal. What was the reaction of the scientific community to this new data? I received a letter from Professor Raphael Kazman of Louisiana State University several months later, January 27, 1977. Dear Dr. Gentry, I have been patiently scanning the letters section of Science since the publication by you and your colleagues of your findings on radio halos. The silence is deafening. I think it can be interpreted as stunned silence. your results will not greatly trouble the engineer, but the impact on the science of geology in possibly changing the accepted views as to the duration of geologic time will be felt for many years. Very truly yours, Raphael Kazman. Soon thereafter, Professor Kazman organized a symposium. It was entitled, "It's About Time, 4.5 billion years." Is the Earth really 4.5 billion years old? When the results of the symposium were written up and published in the September 1978 issue of GeoTimes, here's what was said. However, since the deposits from which the coalified wood was obtained are considered to be at least of Cretaceous age and possibly of Jurassic or Triassic age, the ratio between uranium-238 and lead-206 should be low. Instead, some such halos have been found with uranium-lead ratios ranging from about 2,200 to over 64,000. If isotope ratios are to be used as a basis for geologic dating, then presently accepted ages may be too high by a factor of 10,000, admitting the possibility that the ages of the formation are to be measured in millennia. Translated, that means several thousand years for the formation of coal and all of those geologic formations. This information has remained unchallenged and unrefuted in the open scientific literature since it was published in 1976. We are therefore entitled to draw some rather firm conclusions about the data. Geologists have assumed the Eocene was about 60 million years ago, the Cretaceous about 110 million years ago, the Jurassic 160 million years ago, and the Triassic 225 million years ago. But the results that we presented contradict that information. It's showing instead the simultaneous burial of all these formations about several thousand years ago. These results pertain to the origin and age of coal wherever it is found.
Catherine Hill Bay, Australia. Not far from this coastal area near Flat Rocks Point is an object of extreme geological interest, an ancient tree. The fossilized remains of this tree can be seen extending through over 12 feet of sedimentary layers between two coal seams located here. Years ago, when a mining company excavated the layers exposing the tree, the bottom of the tree could be seen extending down to the lower coal seam. Since that time, the lower part of the tree has broken off. Even now, in its reduced length, the tree extends through layers geologists normally theorize to have taken hundreds of thousands of years to accumulate. But these layers could not have taken long ages to accumulate because the tree would have rotted long before the sediments would have had time to accumulate around it. Rather, this tree is mute testimony to its catastrophic burial by at least two sequences of volcanic ash deposits. As the evidence indicates, the tree was probably buried in a series of closely spaced volcanic ash flows, perhaps similar to the catastrophic burial of thousands of trees at Mount St. Helens in Washington State. But if coal did form rapidly, we expect to find places where geologists have encountered extreme difficulties in explaining its origin by slow accumulation of vegetation. So let's take a closer look at the evidence for coal formation as it occurs in the spectacular Powder River Basin in Wyoming and Montana. The Amex Eagle Butte open pit mine near Gillette, Wyoming exposes the vast coal reserves made visible by the strip mining methods used here. The Eagle Butte mine boasts of coal layers or seams with thicknesses ranging up to 120 feet. Eagle Butte mine is part of a much larger coal-rich area known as the Powder River Basin. This gigantic 10,000 square mile reserve, situated between the Black Hills of South Dakota on the east and the Bighorn Mountains on the west, extends northward to the Yellowstone River in Montana and southward to Casper, Wyoming. The immensity of the Powder River Basin coal deposits has attracted the attention of geologists for decades. Such interest was documented in the May 1993 issue of Earth magazine. The article, Powder River Coal, Geologic Enigma, Environmental Dilemma, included these statements. Powder River's coal seams run remarkably thick and unsullied by other material. Usually unwanted sediment such as clay washes over a deposit before coal seams can get very thick. But Powder River coal is packed in immense strips, some more than 200 feet thick. These seams stretch vast distances up and down the basin. They're hundreds of miles long. They're 50 miles wide, says James McClurg, a geologist at the University of Wyoming. They're not little pods of an acre or two. They're immense things. McClurg, who studied the basin for more than a decade, says no other place in the world has as many seams 50 feet or more thick. But the Powder River Basin is not only an economic resource. To geologists, it's also an intriguing scientific enigma. Geologists have been studying the basin for more than a century, largely to answer a baffling question. How did the seams get so massive? Or more precisely, why weren't the seams diluted by influxes of clay and other impurities before they thickened? As McClurg puts it, how on earth did things remain constant enough so that you can get 200 feet of coal? The genesis of any kind of coal demands a precise sequence of events, however. If you don't get all of them, you don't get coal, explains McClurg. And to get seams more than 200 feet thick, low in impurities and low in sulfur, is a remarkable achievement. He adds, it would be like blindfolding yourself, spinning around and hitting the center of a dartboard 100 times in a row. But if coal did not form slowly, is there any laboratory evidence showing that it can form rapidly? In this demonstration, Robert and David Gentry begin to answer this question.
Earlier we took a piece of wood like this, inserted it in this steel pipe, added some water, and then sealed it up. The next step is to put it in the oven at about 160 degrees centigrade for 2 weeks. Now we're ready to examine the results of this experiment.
As we can see, this wood is now darker in color. It's also softer. A chemical reaction between the steam and the wood under pressure has caused these changes to occur. This specimen isn't coal yet, but clearly the process of coalification has begun.
The question is, would coal result if this experiment, or a variation of it, continued for a longer period of time?
Scientists at Argonne National Laboratory have answered this question in a series of experiments performed in the 1980s. One of the earliest reports about their work appeared in the magazine Chemical and Engineering News in the November 21, 1983 issue. On page 42 of this issue, we read the following quote: "Chemists at Argonne National Laboratory have succeeded in making a type of artificial coal from naturally occurring materials. The process is much less severe than formerly thought to be necessary and provides some new insights into coal structure and how to alter it." Later, after their published reports appeared in the science journal Organic Geochemistry, the British science journal Nature reported on the success of their experiments. On page 316 of the journal Nature, March 28, 1985, we read the following: "Winans and his colleagues at Argonne National Laboratory have taken less than 1 year to prepare a thoroughly characterized synthetic coal. The material they produce is indistinguishable from the real thing by all the techniques so far applied to it, and its synthesis raises many interesting questions in coal chemistry." To understand their results, let's first note the basic structure of wood. Two major wood components are cellulose and lignin. The lignin basically acts as a binding agent for the cellulose fibers. Several variations of the argon experiment were run, but the successful formula combined lignin and clay with heat, about 150 degrees Celsius, in the absence of oxygen. Over a period of about 8 months, artificial coal was produced. The rapidity with which coal can form when steam interacts with wood under pressure leads us to ask, can steam or hot water also produce the rapid transformation of organic matter to oil? An article, Water, Water Everywhere, published in the February 20, 1993 issue of Science News, answers this question. Researchers at Exxon discovered water acted an essential part in the formation of oil. Efforts to synthesize oil met with failure until very hot water was added to the reactor vessel containing the source rock sample. When this was done, a layer of oil was found on top of the water at the end of the experiment. This result proves there is an alternate path to the production of oil in the earth, with superheated water playing a major role. The article indicated this discovery could wreak havoc with established ideas about oil formation. Actually, however, other natural events are already wreaking havoc with conventional theories. Incredibly enough, certain researchers, one at Oregon State University, have published reports showing evidence of present-day oil formation in the Guaymas Basin in the Gulf of California. Right now, in the Gulf of California, below 6,000 feet of water, is an accumulation of organic sediments derived from marine algae and other organic sources. Below this, superheated water is being pushed up by a deep heat source through these sediments. Oil is being formed in the interaction of organic sediments with superheated water. This hydrothermal oil from the Guaymas Basin is virtually indistinguishable from crude oils obtained from wells drilled in the earth. The implications of this discovery can hardly be overestimated. The possibility must be entertained that the genesis of the reservoir crude oils abundant throughout the world may be explained by hydrothermal processes similar to what's happening in the Guaymas Basin. But instead of an open dispersion of oil directly into the seawater, a closed system could easily be visualized where a reservoir of crude could be collected. It is conceivable that a worldwide flood was instrumental in the production of the tremendous oil reserves of the Middle East and elsewhere. The vast amounts of vegetation buried by such a flood, mixed with superheated water similar to that detected in the Guaymas Basin, could produce oil in the volumes we see today. Depending on the burial conditions, the organic matter would be transformed to either oil or coal. Is there a model of Earth history incorporating these features? One which allows the formation of the world's large oil and coal reserves over a much shorter time than has been previously thought possible?
What about a model based on the record of Earth's history given in Genesis? The Bible describes Earth being called into existence about 6,000 years ago, an Earth originally covered with lush vegetation, then devastated by a worldwide flood about 1,700 years later. This timescale certainly fits with all the scientific discoveries I've made, and just as certainly, water once covered this Earth. In 1927, Noel Odell discovered marine shelly fossils near the very top of Mount Everest. Mountains rising out of the waters is how the Bible describes the end of the worldwide flood. According to that description, the shells near the top of Mount Everest are no surprise at all. And coal and oil, are they the result of the rapid devastation and burial of lush vegetation by a worldwide flood? If so, what about the worldwide flood could have caused such rapid burial? The Bible speaks of the fountains of the great deep breaking out, a strong reference to volcanic eruptions in the pre-flood ocean basins.
This is significant because ocean survey researchers recently found an area on the Pacific Ocean floor thickly concentrated with over 1,000 volcanoes. The size of this area is approximately the same as Washington State. Additional ocean floor surveys may well yield many more such discoveries. The likelihood of extensive volcanic activity during the biblical flood leads us to consider one of the most famous volcanic eruptions in modern time. On May 18, 1980, a giant landslide on the north face of Mount St. Helens in Washington State accompanied an explosion equivalent to 20 million tons of TNT. This lateral blast of superheated steam, volcanic ash, and dirt leveled over 150 square miles of forest, snapping huge Douglas firs like toothpicks. The landslide debris plunged into Spirit Lake, causing a colossal water wave which washed over the adjacent mountainside over 800 feet above its pre-eruption water level. An average thickness of 300 feet of new sediment dumped into the lake has caused its surface level to be almost 250 feet higher than before the eruption. A massive number of trees felled by the blast were washed into Spirit Lake by the giant water wave. The power of catastrophically driven water to accumulate and bury extensive amounts of vegetation can easily be seen here. The floating log mat on Spirit Lake is only about half its original size because the rest of the logs have sunk to the bottom. If Mount St. Helens had erupted underwater, huge tidal waves hundreds of times larger than the Spirit Lake water wave would have caused the erupted material to be carried over much of the Earth before settling. If thousands of these volcanoes were active, we can begin to imagine the destructive effects a worldwide flood would have had on the topography of the Earth's surface. This leads us to ask, could such a worldwide flood described in the Bible also be capable of explaining other geological phenomena, such as the Grand Canyon? Some geologists would have you believe that sedimentary deposits were laid down over many millions of years. What they want you to believe is just not true. The fact is, the geology of the Grand Canyon fits a model based on the occurrence of a worldwide flood. In an attempt to learn where the flood waters came from, where they went after the flood, and what geological events occurred during the flood, we went to Dr. Walt Brown, the former Chief of Science and Technology Studies at the Air War College and an associate professor at the U.S. Air Force Academy. His development of the hydroplate theory provides the key that unlocks many mysteries about the flood and its effects.
We can see on our planet 17 very strange features that can now be systematically explained as a result of a cataclysmic global flood whose waters erupted from subterranean chambers with an energy release exceeding the explosion of 10 billion hydrogen bombs. This explanation shows us just how rapidly major mountains formed. It explains the coal and oil deposits, rapid continental drift, why ocean floors have huge trenches and hundreds of canyons and volcanoes. It explains the formation of the layered strata and most of the fossil record, the so-called ice ages, and major land canyons, especially the Grand Canyon. The pre-flood Earth probably had one very large supercontinent containing lush vegetation, seas, rivers, and minor mountains. According to the hydroplate theory, the pre-flood Earth had a lot of subterranean water, about half of what is now in our oceans. This water was in interconnected chambers forming a thin spherical shell about half a mile thick, perhaps 10 miles below the Earth's surface. Increasing pressure in the subterranean water chamber stretched the overlying crust just as a balloon stretches when the pressure inside increases. Failure in the crust began with a microscopic crack which grew in both directions at about 3 miles per second. The crack, following the path of least resistance, encircled the globe in about 2 hours. As the crack raced around the Earth, the overlying crust opened up like a rip in a tightly stretched cloth. The subterranean water was under extreme pressure because of the weight of the 10 miles of rock pressing down on it. So the water exploded violently out of the rupture. The high-pressure fountains eroded the rock on both sides of the crack and even threw up the limy contents of many pre-flood seas. Huge volumes of sediments settled out of this muddy water all over the Earth. These sediments trapped and buried plants and animals, forming the fossil record. The flooding uprooted vegetation, moving it to regions where it accumulated and quickly became coal and oil by processes we can duplicate in the laboratory today. Experiments show that as erosion widened the rupture, its width became so great that the compressed rock beneath the subterranean chamber sprung upward, giving birth to the mid-oceanic ridge that wraps around the Earth like the seam of a baseball. The continental plates, the hydroplates, still with lubricating water beneath them, slid downhill away from the rising mid-Atlantic ridge. After the massive, slowly accelerating continental plates reached speeds of about 45 miles an hour, they ran into resistances, compressed, crushed, thickened, and buckled. The portions of the hydroplates that buckled up formed mountains. Those that buckled down formed ocean trenches. This is why these features are generally parallel to the oceanic ridges from which they slid. The hydroplates, in sliding away from the oceanic ridges, opened up very deep ocean basins into which the floodwaters retreated. Every continental basin was naturally left brimful of water, producing many post-flood lakes. Each lake that grew from rainfall or drainage from higher elevations spilled over its rim at the lowest point of the rim. That eroded a little notch in the rim, allowing even more water to flow through the notch faster, cutting the soft flood-deposited sediments even deeper. This process accelerated until all the lake's water dumped through a very deep slit, forming a canyon. The largest of these was the Grand Canyon. North and east of the Grand Canyon was a huge lake that I have identified and named Grand Lake. Its dumping released more water than is in all 5 of the Great Lakes combined. Grand Lake spilled over its rim, eroded its dam, 20 miles south of Page, Arizona, catastrophically forming the Grand Canyon within a few weeks.
Rapid deposition of flood deposits from tidal action means there was little time for erosion to occur between successive layers. On the long time scale envisioned by evolutionary theory, there should be considerable evidence found of erosion and infilling by successive geologic formations during the weathering expected over millions of years. The geological layers of the Grand Canyon are remarkable in showing little or no evidence of erosion between different layers. Instead, we see pancake layering, very much consistent with the rapid deposition envisioned by the flood model. Erosion did not occur until all of the layers had been deposited. But how rapidly could the canyon itself have eroded?
Freshly laid down sediments would still not have completely hardened into rock, which allows the possibility that erosion of the canyon could have taken place far more easily than if it had hardened into rock, as evolutionary theory has assumed.
However, under the right conditions, water can rapidly cut its way through the hardest of rocks, such as the granites at the bottom of the Grand Canyon. Those conditions involve cavitation.
Cavitation is the rock pulverizing process associated with water flows greater than 100 feet per second. As water detaches from irregularities in the bedrock channel, vacuum bubbles are produced, inflicting hammer-like blows on the bedrock surface, literally converting the rocks into powder.
A modern example of rapid erosion of bedrock from cavitation comes from Glen Canyon Dam on the Colorado River just above the Grand Canyon. Excessive snowfall from the high country of the upper Colorado River Basin in late spring of 1983 caused excessive runoff that poured into Lake Powell at rates of up to 148,000 cubic feet per second. This rapid inflow threatened to overflow Glen Canyon Dam. To control the high flow rates, the power plant was run at full capacity, releasing 28,000 cubic feet per second through the turbines. Then the outlet tubes were opened to drain another 17,000 cubic feet per second. This was still not enough. The emergency situation required engineers to risk damage to the spillway tunnel. And on June 15, the 40-foot diameter left spillway tunnel was opened to drain an additional 13,000 cubic feet per second, which was then raised to 17,000 cubic feet per second. Then on June 28, the flow was increased to 32,000 cubic feet per second. At this point, the water exiting the tunnel became red, and noticeable ground vibrations, earthquakes, were felt by engineers. Large blocks of concrete and bedrock came hurling from the 40-foot diameter tunnel. After closing the spillway tunnel, the survey team discovered extensive cavitation damage. The 3-foot-thick steel-reinforced concrete lining of the tunnel was penetrated by huge pits. At an elbow where the tunnel levels out, a hole 32 feet deep, 150 feet long, and 40 feet wide was cut through the lining into red sandstone bedrock. This hole required 63,000 cubic feet of concrete to fill. The repair process to the enormous hole shows the vast extent of the damage. The speed of erosion in the Glen Canyon Dam spillway tunnel occurred very rapidly during the period when the red color of water appeared and ground vibrations were generated. It is possible that cavitation was pulverizing concrete, steel, and sandstone at the rate of 1,000 cubic feet per second during the peak period of erosion. The destructive effects of cavitation at Glen Canyon Dam tell us the Grand Canyon could have been eroded very quickly by the sudden release of a huge volume of water above the canyon. But where did the water come from, and what caused its sudden release? Dr. Brown's studies on the Grand Canyon provide one of the best answers.
Most people are told that the mighty Colorado River carved the Grand Canyon over millions of years. But if people could study the canyon from an aircraft, they could see its vastness and how tiny that river is in relation to the canyon itself. There is no river on Earth that could carve this big hole in the ground, even over billions of years. If the Colorado River carved the Grand Canyon, the first question we should ask is, where did all the eroded sediments go? There should be a very large river delta at the end of the Colorado River. It's not there. Furthermore, geologists can't find a huge river delta anywhere near this part of the world. So we need to ask ourselves, where did the dirt go? At several places on this platform that overlook the Grand Canyon, there are small mountains or buttes whose horizontal layers tell a fascinating story. The layers line up with each other, so obviously they were at one time connected. Something must have come along and removed a several thousand foot thick layer of softer material that was once where we now are. So we need to explain not only where the dirt from inside the vast 200-mile-long canyon went, but also where did the thousands of feet of dirt go that was once above where we are now and spread out for tens of thousands of square miles. This particular formation, called Red Butte, not only still has some of these horizontal layers, but there is another clue sitting on top. The topmost layer is a lava flow. Lava only flows downhill. Therefore, at one time, the land surrounding the top of this butte must have been even higher. So again, where did all that dirt go? Grand Lake spilled over and eroded its dam catastrophically, forming the Grand Canyon to the southwest within a few weeks. One other large post-flood lake that geologists recognized was once near here was Hopi Lake. As Grand Lake catastrophically dumped, I believe it eroded the western boundary of Hopi Lake, causing it to also spill out. Where did all the dirt go? It was spread out over southern Arizona and parts of California and Nevada rapidly.
The evidence supporting the biblical worldwide flood about 4,300 years ago is mounting. For the Grand Canyon, the flood explains how the sedimentary layers were rapidly deposited as the waters rose, and how they were quickly eroded as the waters subsided. We have also seen where the dirt went. And just as we have seen evidence of the rapid burial of pre-flood vegetation to produce today's coal and oil, we will now see fossil evidence of rapid burial of pre-flood life forms. Indeed, some of the most remarkable evidence of rapid deposition of flood sediments comes from well-preserved fossils found in certain parts of the earth.
Perhaps the best fossil evidence for the rapid burial of plant and marine life is found in southwestern Wyoming at Fossil Butte National Monument. During the past 100 years, scientists and private collectors have collected thousands of almost perfectly preserved fossils from sites within the monument, especially here at Fossil Butte itself. It's an amazingly diverse collection of fossil turtles, palm fronds, crocodiles, leaves, insects, branches with nuts still intact. There are even fossil stingrays, whose skeletons of cartilage are known to disintegrate rapidly, proving that burial of all these life forms was indeed quite rapid. But this isn't all. Perhaps the most spectacular evidence of rapid burial of all the fossils within the monument are the billions of the more than 20 kinds of fish. This slab of rock in the Monument Visitor Center, which measures about 9 feet by 5 feet, shows vividly just a few of that number. Amazingly, many of the fish retain not only their entire skeletons, but their teeth, delicate scales, and skin as well. The vast number of fossil fish at Fossil Butte has left evolutionary geologists with a vast unsolved mystery. In two sections entitled Ideal Conditions for Fossil Making and Unsolved Mysteries, the National Park Service's brochure on Fossil Butte reveals the contradictions that result when using an ancient Earth time frame to explain rapid burial. On one hand, it speculates on the existence of a lake, wherein many animals and plants probably died natural deaths. On the other hand, the evidence forces the conclusion that, on several occasions, huge numbers of fish were killed suddenly. The brochure then equates those several occasions to rapid burial by precipitation of calcium carbonate. the primary rock mineral enclosing the fossils, year after year for hundreds of thousands of years. This is a truly incredible scenario, to have such a vast number of fish reproducing within a short time, only to be wiped out by a succeeding catastrophe a year or so later, and this to be repeated several 100,000 times. Paleontologists should long ago have seen the fallacy in this scenario, if for no other reason, because of the beautifully preserved fossil palm fronds. Put very simply, palm trees don't grow in water, and their fronds are not ripped off by gentle breezes. Only a catastrophe of huge proportions can account for the perfectly preserved fossils at Fossil Butte. The rocks there are, like many in the Grand Canyon, primarily calcium carbonate. They all had a common source, the interaction of volcanic gases with lime thrown up from the basins of the pre-flood seas. This commonality, together with the evidence of rapid deposition and burial, tells us plainly that Fossil Butte and the Grand Canyon originated in the same great event, the catastrophe of the worldwide flood. But is there any other evidence which would confirm that Fossil Butte is only as old as the flood? The answer is yes. Geologists have repeatedly identified the Fossil Butte site as belonging to the Eocene, which they assume was 50 to 60 million years ago. But we have already seen from my studies on coalified wood and the chart on the collapse of geologic time that the Eocene fits into the framework of a worldwide flood only several thousand years ago. So there is no question that the entire Fossil Butte occurrence fits only within the framework of a worldwide flood and a young age of the Earth. And there is more. Not everything was buried on the first day of the flood. The waters were rising for 40 days. Land animals large enough to survive part of that period left a remarkable record of their efforts to escape the flood's rising waters. That record is found in coal, and it is truly fascinating. Dinosaur tracks in coal. Amazing. Extraordinary. How in the world did they ever get there? Obviously, in the past, there was a huge seam of vegetation in this area. Dinosaurs were walking around on top of that vegetation before it turned to coal. But how long ago was that? How old are the dinosaurs? That's what we want to know. This other dinosaur track tells the story. It's right adjacent to one of these coalified logs here in this coal mine in Price, Utah. In fact, it's only about 100 feet away from the coalified log that we saw earlier. So we know that whatever the age of the coalified wood, the dinosaurs were of the same age. In the coal mine, we saw two dinosaur tracks. Were those the only two dinosaur tracks in the coal mines here in eastern Utah? Not at all. Here in the College of Eastern Utah Prehistoric Museum, look what has been taken out of these coal mines. Look at all these dinosaur tracks, different sizes. Some flesh-eating dinosaurs, some plant-eating dinosaurs. Why were they all together? To answer that question, let's look at the Kenilworth Mine fossil map. It says there are at least 8 different track types within 100 meters on the mine's roof surface. Over here on the map itself, here we can see all the tracks and the coalified logs. According to the sign, those dinosaurs were tromping around in a swamp. Common sense tells you that can't be true. There's no swamp in the world that will preserve such tracks. All those dinosaurs were together for a reason. They were trying to escape the rising waters of a worldwide flood. These charts help illustrate how dinosaur tracks could have formed at the time of the flood and why they exist in coal today. The pre-flood earth was covered with lush vegetation, a scene of beauty everywhere. Then came the flood. Torrential rain and the fountains of the great deep bursting open caused Earth's lush vegetation to be swept up in the flood's rising waters. This vegetation accumulated in great mats and then was deposited by the ebb and flow of tidal waves produced by volcanic activity in the pre-flood seas. Each tidal action left its deposit of sediment within or over the layer of vegetation. The dinosaurs, being quite heavy, were able to survive many of the early tidal actions as they sought to escape the rising waters of the flood. When the tidal waters briefly receded, the dinosaurs continued their search for higher ground, leaving their tracks in the sediments that were freshly deposited over the vegetation. At times, their great weight caused their tracks to penetrate the sedimentary layer into the mat of vegetation. That mat of vegetation has since turned into coal, and wherever the dinosaurs left their original imprints, there we still find an indelible record of their tracks in coal today. If all these dinosaurs were congregating together and swept up by the rising waters of the flood, we might also expect that they would be buried together. And indeed, here at Dinosaur National Monument in Vernal, Utah, we see a giant fossil dinosaur graveyard. The time has come to draw some conclusions about the age of the dinosaurs and the age of the fossil fish found at Fossil Butte National Monument. Here at Dinosaur National Monument, there's a sign that says these dinosaur bones are 145 million years old, the so-called Jurassic era. But we know that can't really be true at all. Remembering our early results on the coalified wood, there we found the collapse of geologic time. The Eocene, the Cretaceous, the Jurassic, and the Triassic, we found were all together only several thousand years ago. The fossil fish in the Eocene, the dinosaurs in the Cretaceous, the Jurassic, and the Triassic, all again collapsed to just several thousand years ago, buried at the time of the worldwide flood.
This evidence disputes the whole evolutionary theory of life's origin and development. But some may ask, hasn't science proven dinosaurs lived hundreds of millions of years ago? It's just the opposite, according to the new evidence described by Dr. Andrew Snelling of the Creation Science Foundation of Australia.
This May 1995 issue of the journal Science has a picture of a bee enclosed in amber. It's similar to the bee in the specimen of Dominican amber that we have here. Geologists think that both specimens are between 25 and 40 million years old. And now that's a big problem for them because they have now extracted from the abdomen of the bee bacteria, live bacteria. This result supports earlier findings of over 1,000 types of bacteria from other insects, some that date with the dinosaurs. Until now, many evolutionists thought those findings were due to laboratory contamination. They just couldn't believe bacteria could survive for tens or hundreds of millions of years. But this new result, coming after 4 years of careful analysis, rules out laboratory contamination. As a scientist, the reason why I believe the bacteria were found in the bee in the Dominican amber and in other fossils previously of the same age as the dinosaurs is because they're really all quite young. These have to be the result of being encased and buried in a worldwide flood, a catastrophic flood only several thousand years ago. All this agrees with the evidence for the young age of oil and coal that we've already seen, and clearly is consistent with the view that the varied life forms found in nature originated with the supernatural events of Creation Week only about 6,000 years ago.
Evolution assumes granites formed by slow cooling over billions of years. The time of cooling, or presumed age, is obtained by measuring the present radioactive decay products in the granite, and assuming they accumulated only by slow, constant radioactive decay. Because evolution equates radioactive age with the time of cooling, any evidence showing granites formed rapidly essentially shows their simultaneous creation. Thus, the premise of constant radioactive decay and the inference of great age is invalidated.
And indeed, there is scientific evidence for their simultaneous creation. Etched within the granites are beautiful microspheres of coloration produced by the decay of a certain radioactive element known to have only a fleeting existence. Using a simple analogy, Alka-Seltzer bubbles in water can be retained only by rapid freezing. Similarly, the microscopic record of fleeting radioactive decay in the granites is there only because these rocks were instantly created in solid form. If these rocks had formed by slow cooling, as evolution claims, the radioactive traces would have disappeared in the melt without leaving any visible record. This record of instantaneous creation is found in granites worldwide. Moreover, its existence in granites of vastly different radiometric ages shows they were all created at the same time. This collapses the whole foundation of geologic time. The hundreds of millions of years of cooling time that geologists have thought necessary to form the giant monolith El Capitan is reduced to less than a few minutes.